Okay, going to do some more graphing of exponential functions, and this is y equals negative 2 to the x. So again, we don't have a shift, so our reference is our 0, 0. Well, that's our origin. So we just put some values in. When x is 0, well, anything to the 0 power is 1, but this is going to be negative 1. So again, just cover that up. 2 to the 0 power is 1, but I have negative 1. 2 to the 1 is 2, so I have negative 2. And 2 to the negative 1 is 1/2, but I have a negative in front, so that's negative 1/2. So be careful with that. So let's take a look at these points. So 0, negative 1. 1, negative 2, and negative 1, negative 1/2. And as before, we could get another couple of numbers in here. When x is 2, 2 squared is 4, so we have negative 4. And when x is 3, say negative 4 here. 2 cubed is 8, and I have negative 8 in front, so negative 8. This is 1, 2, 3, negative 8. And there you go. So we graph this again. This is our horizontal asymptote. In other words, my graph is getting closer and closer to this, and the equation of that horizontal asymptote is y equals 0. And I'm going to get closer and closer to that, and then it's going to kind of move down exponentially. Something like that. And since as I move to the right, my vertical values, or my vertical values, or the value of the function, or the vertical position of the function, is going down, this is what we call exponential decay. In other words, we're not growing, we're decaying, we're getting smaller. And what's the domain of this function? Well, the domain, again, it looks like it's going from negative infinity to infinity. But the range looks like I'm going down to negative infinity. So when you're going down to negative infinity, the negative infinity always goes to the left. And it looks like the highest it goes to is 0, but not equal to 0. It goes almost up to 0. Again, remember, it's asymptotic to this line y equals 0. So it gets closer and closer to 0, but never touches it. So that's exponential decay. Now in this case, remember the number that's in front of the base is the a. In this case, a is negative 1. So remember, we have these forms y equals a times b to the x. And in this case, it's y equals negative 1 times 2, and I guess I could put the b in parentheses, 2 to the x. So you can see in this, x. So in this case, you can see that get this up a little bit higher. There you go. So in this case, you can see that the a is going to be negative 1. So the a is negative 1, and the b is going to be 2. So when the a is negative, we have exponential decay. When the a is positive, we have exponential growth. Okay, let's try another one here. So graph y equals 1/3 to the x. So we try to set up our values, our table of values. When x is 0, anything to the 0 power is 1. So that's easy. When x is 1, 1/3 to the first power is 1/3. And when x is negative 1, now remember 1/3 to the negative 1, we just kind of reverse it, so that's just going to be 3. or flip it, I should say, not reverse it. So those are your values. Okay. All right, so I put these points in. 0, 1. 1, 1/3. And negative 1, 3. Negative 1, 1, 2, 3. There we go. That'll give you a contour of what's going on. Okay, and there's your curve, and as I go from the left to the right, what are the values doing? They're getting smaller, so it looks like it's exponential decay. And the domain of this function looks like it's going to be negative infinity to infinity. And the range looks like I'm going from 0 up to infinity. And the horizontal asymptote, again, is this line y equals 0. The graph gets closer and closer to 0, y equals 0, which is the x-axis, but never touches it. So it's decaying, it's getting smaller and smaller and smaller. Okay?